All right. So pattern matching with regular expressions. Regular expressions is a fancy way of doing Control F that you guys are used to in Microsoft Word or out on a website, something like that, where you're wanting to search through your data to find some kind of pattern of text. I'll be honest, regex is the most difficult topic in any programming language. Okay. It's complicated. It doesn't make sense. It's not very straightforward. Most people don't memorize regex. All right. I'm going to show you tools on how to do regex. That is what most people do that are programmers in real life. Even programmers that are coding tons and tons of this stuff, they do not freehand it. They use a tool to build out the regular expression that they want to use. Okay. So I give you a tool to use. Please use that tool. You can go off and use some other stuff if you want to in order to build your regular expression. I'm fine with that as long as it matches what you need to do on this side. Okay. So regular expressions, what this allows us to do, like I said before, is to be able to do a search. And so we know certain things, for example, a phone number, right? A phone number is typically seen like this: 3 digits, a dash, 3 digits, a dash, 4 digits here in the US, right? But that is not the same thing as 411555123, right? Or in other words, 4,155,000,000, et cetera, et cetera. Those are not the same thing. And that's because this has a very specific style. Now, across the world, this can be a little different, right? So instead of 415 dash, it could be 415 period, 555 period, 1234, right? You may have extensions, you may have other stuff. Email addresses all have some handle at something.com, .net, whatever else goes in between there, right? So as you build those patterns out, we can search through data to see if it ends up being the same. When I go on this website and I do a Control F and I look for the word the, it's going to find every the. But there's a couple different problems here, right? That THE, it's going to find in the word other. It's going to find it in then, whether, either. All of those have a THE. So we would have to be very specific if we're wanting the word the, where it starts and ends with those particular use cases. And that's actually something that we're going to work on this semester. Hint, hint, it is on assignment 4. You will search for the word the and find a good way to do the word the. All right. So we can write our own functions. For example, def is phone number. And what this function would look like is we take in some string of text. We're going to check to see if the length of that text is 12, right? Because there should be 12 characters inside of a phone number. And this is assuming the dashes, right? So you'd have 3 characters, a dash, 3 numbers, a dash, 3 numbers, a dash, 4 numbers, right? So if we did a length check on that to make sure it's not equal to 12, then we would return false. If it is equal to 12, then for I in range of 0 to 3, in other words, check the first 3 numbers. If not text is decimal, aka if that character is not a decimal, then return false, right? Decimal being a number is what it's saying. Then if the first 3, after the first 3, in this case, the 4th index, right? Index 3, the 4th index, if that one's not a dash, return false, et cetera, et cetera. So it's looking very specific to make sure that you are passing it this text only. Okay. This is what we would have to do in a regular Python class or in a regular function. We would have to write out this real long if, elif, chain, everything coming on down. Cool. What we can do is use regex to do the same thing and make that a little bit easier. We could also chunk through this message to see if we can find it and kind of move through there as well. To find patterns of text with regular expressions, we're going to use regexes, which are going to have different character denominations. So for example, a /D is going to be equivalent to a digit character. All right, that means anything from 0 to 9. So if we had the regex of /D/D/D dash /D/D/D dash, and then 4 more of those, sure, then Python would match those as numbers for every place that there's a /D. Okay. You could also shorthand that a little bit, and you can make it look like this, where you have /D brackets 3, meaning that the count is 3. You can do that dash again, 3, and then 4 in order to match that same format. So to play with this in Python, we have to import a module called re, or regular expression. So import re. Okay. Then we have to build our phone number regex, in which case we will do an re.compile. We do a bracket. Now we're using a raw string, right? Because what would happen if we didn't? We learned this last week, right? It would try to interpret these forward slashes, right? We would have to run escape characters before every single one of them. So right now it thinks it's escaping the D character, and that would not work for what we would want to do. So you must put the R in the single quotes and then have your actual pattern inside of here. Okay. So this is something that you would copy and paste when you guys are playing with regex. You would start with RE, import RE, then set up your phone number regex equals re.compile, and inside there, you're going to put whatever string that you're trying to match against. From there, you would use MO, which means match object. Okay. You could use whatever characters you want. MO is just a generic one that we tend to use. MO equals phone number.regex, this thing you just created, .search. And .search is then going to search through some text. Okay. In this case, we passed in the text. If we gathered information from the user, we would pass that variable into search. Make sense? From there, we would go ahead and say print phone number found, mo.group. And mo.group is going to be whatever matched object came out of this search query. Okay. Again, it's like pressing Control F and then searching through text that a user gives you in Python.
So in that group, you can make that variable anything, and we just put in that group of character or that group of text.
This mo over here, yes. Yeah, so if we call this add for whatever reason, then it would be add.group in order to pull that out. Yep. Okay, so when you do a search, it's going to find the first result and then return that back to you. When you print out the mo.group, it would go ahead and replace that with all of your numbers just like you had before. Okay, so in order to set up regular expressions, you do an import re. You're going to set up a regex object using re.compile. Remember, you must use a raw string. You're going to pass whatever string into the search method so that we can figure out if there's anything in there, and then mo.group. If mo.group doesn't get anything, it will just return a blank. Okay, so you could do a check. If mo.group equals nothing, then you had no search results at that point. Okay. We can also do, notice that did one group for that whole regex expression we did. We can also do individual groups with parentheses. So if I did parenthesis /d/d/d parenthesis dash, and then this one here, this would allow us to get back two groups, in which case we would have group 1, which is your what in a phone number? Area code. And then you're also going to have mode 2, which gives us the actual phone number, right? Mo.0 is going to be the whole thing, and mo group is going to be the whole thing. Does everybody see how that works? So when you use parentheses inside your regular expression in here, it's going to allow you to set up multiple groups so that we could assign that later. So we could actually assign the word area code to mo group 1 and number over to the back half of the number. The idea being that we could store information for all that if we wanted to. Or we could use a multiple assignment trick in something like this. Area code main number equals mo groups. That's going to allow you to thereon use area code in your program and main number from there on out. Everybody see how that kind of works? You can do the same thing here. So this regular expression is showing you how that works. This, notice there is a slash parenthesis here. When you do a slash parenthesis, it's going to escape that. We want to do that because we want to match for those that actually put the area code in parentheses. So we would have to have this string if we wanted to match on the ones that have that. It's very, very particular when you build out regex. Okay. Again, there may be other characters you want to escape. For example, all of these have a special meaning in regex. So you would have to escape them in order to have regex ignore them at that point. All right, I'm going to pause here. If you go back to our Blackboard section, you're going to see this regular expressions 101 link. All right, this is your tool. This is your friend. So you click on that link and you're going to get regex 101 as a website. Okay. On the left-hand side, you're going to click on Python. This up here is where you can start to build your regular expression. This test string allows you to put some test data in there so we can see if it's actually going to find it. So we could say my phone number is 785-628-4758. Down over here at the lower right is going to be your reference for what all those meant. So remember, a /d, in this case, lowercase d, means any digit. If we do a capital D, it means any non-digit. So a lowercase means what you're looking for. A capital typically means the opposite of that. Does that make sense? So in our case, if we go back and look at our regular expression we had /d, 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 dash, /d, 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 dash, /d, 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 /d. Notice over here in our test string, it ended up matching on this particular pattern. Now, if I just had /d, we'll notice it matched, but it matched 10 times because I have 10 numbers over here. Does everybody see how that worked? So if I just have /d, well, then it finds all the numbers that are in this text that I have for an example. It isn't until I build out the exact pattern I want. For example, if I do the first 3 /ds, right, that finds 3 of them. It found this 785, it found the 628, and then it found the 475 because that also matches 3 of them. Yeah.
So if you're looking for a letter or just specific words, you can put your slash and then you put the string inside of it, or no?
No, so you would actually have it match in here. So if I wanted the word is, I would just put is inside there.
That's so simple.
Right, but that's only going to match on every is.
Yeah.
So say I have is and another word like
Isn't.
It's going to find the is and isn't. So I would only want to match specifically on where it started and ended with what I had up here. So to do that down here at the bottom, I could say exactly how many I want to do, or the start of end of string, or a word boundary. That's a good one. Hint, hint, wink, wink. On this word boundary down here in the lower right-hand corner, you might want to say something like /b, is, /b, is, and that will give you just the word is. Okay, notice how it didn't match and isn't. It just found the word is. All right. So again, those /ds, this will allow you to match on a phone number if you set it up correctly. If we were to put those in parentheses like we just learned, and I grouped this section here, then over here, it's going to tell me exactly in the upper right what matched. I matched the entire telephone number. Group 1 matches to 785. Group 2 matches to 628-4758. So the idea is that you would dump a bunch of test data in this lower part, make sure you're getting what you want, build your regular expression with either these quick references, and just copy and paste this part into your Python script. Whole lot easier than trying to test, run. Use this tool. Everybody uses this when they program. There used to be specific software specifically for building regular expressions back in the PHP days, and programmers bought it all the time. Nowadays, there's too many free tools out there. All right. So when we come over here and show you this, if you wanted to match on multiple groups, you would use the pipe symbol. Does everybody know where the pipe symbol is on your keyboard? Usually right above the enter key, right? You're going to have a straight up and down shift, and then that key will get you the pipe symbol. All right. So if we had a regular expression of Batman pipe Tina Fey, it's going to match on either or. So it's going to match on Batman or it's going to match on Tina Fey. And it's going to give me the first result when I use search. So if I send Batman hype Tina Fey and I send the text of Batman and Tina Fey, the first thing it's going to match on is Batman, and therefore Mo group will end up being Batman. Does everybody see how that worked? If I was to search for Tina Fey and Batman, then it would find Tina Fey first and therefore give me that result back. Remember, search is just going to find the first result into whatever text that you pass it. Here, we're passing it very little text. I may pass in half a book and have it search through something, right? Just like you would with Control F in a Word document, it would search through everything and find the first one. Or Control F here in my browser, it's going to find the first result. Okay. If you want to find all of those results, then you would use the find all method. Okay. We're going to talk about that here in a little bit, but you would use a find all method to get all the results. You could use something like bat, and then we want to group either man, mobile, copter, or bat. This will find Batman, Batmobile, Batcopter, and Batbat. Right? So this gives us all the ways of finding different endings, and it would group them accordingly if we asked it to. So for example, if I send it the text Batmobile lost a wheel, it would find Batmobile, and the first group it would return the mobile is what it ended up finding. So you can get very detailed on your Control F. We are used to hitting Control F, typing in a word, and it gives us back a result. If we wanted to trim that down, like you would in Word, you would have to tell it to match to a regular expression. So you'll find regular expressions in Word. You'll find them in Notepad++ if you guys use that. Any of those kind of things, when you do a search, has the ability to do regular expressions. You can also do optional matching with a question mark. For example, say we want to catch either Batman or Batwoman. We would say bat, parenthesis, whoa, parenthesis, the question mark would be man. Means that man is optional at that point. So, or man is included, this whoa is optional. So the Adventures of Batman, it finds Batman. Adventures of Batwoman, it would end up finding Batwoman with this one regular expression. I know this seems really fast. And again, this is a very dense topic. The only thing you can do is practice with it and play with this tool in order to really figure it out. And even then, I'm not asking you to memorize every single one of these. All right.
You'll always have access to it.
You should always have access to a tool. So if we look back at our regular expression for a phone number, if we update that this time to where we put in a question mark after those first /Ds, that means that we will find not only this phone number, but we'll also find it if they leave the area code off. So a well-written regex is going to save you from having to do multiple different versions of a regex all the way down. Otherwise, I'd have to find a regular expression to match this and one to specifically match this inside of there. A whole lot of if statements, where in this case, if I craft this right, I can find just the ones I care about. Inside this one, you can use an asterisk, and an asterisk is going to say one or more of the results going in there. So if we go back to our Batwoman one and we use an asterisk instead of a question mark, we are going to look for Batman. We'll find Batman. Batwoman, we would find Batwoman. If I search for Batwoman, then it will actually find that as well. Does everybody see what happened there? It's looking for the whoa, and it's looking for either 0 or more than that. That's what an asterisk means. If we want one or more, we look for a plus sign. So in this case, it requires that we have at least one match, in which case we would only find Batwoman. We would never find Batman. Does everybody see how that works? So if we use a question mark, it's optional. If we use an asterisk, it's looking for 0 or more. And if we use a plus sign, it's looking for 1 or more, meaning it would have to have at least one whoa in order to match. If you want to match a certain number of times, you can use curly braces. And so curly braces with a 3 means you will match specifically for 3. If you do 3 comma 5, it will go 3 up to 5, right? Just like we were doing with our telephone earlier. So if we say ha 3, it would say ha ha ha. We would do just ha. It would not match because we required a specifically 3. Where this is going to be handy is if in your midterm projects, you guys are analyzing data, et cetera, and you're trying to parse a bunch of data going through and get the information you want, you may have to use regex to clean up that data so you can get just the piece you care about. Does that all make sense? So if you're gathering a bunch of input from people and it could be a bunch of erroneous data and you're trying to clean up that data, that is where you typically use regexes for. So now you all are not going to do data science projects. You're going to stay in a different lane so you're not writing regex. It's fine. I get it. But there are handy versions of doing regex and why you would use it. Okay. There's a whole bunch of other options in here. I'm going to kind of glaze through these because they're not going to necessarily be relevant unless you're going to use regex. And if you are, use the tool. All right. Everything I'm talking about is available right down here in the lower right. It's going to even have examples. So for example, here was your 3. Here was your 3 or more. Here's your 3 to 6 option, somewhere in between there as well. Okay. Greedy means that we're going to be matching for that. By default, we're going to be looking for ambiguous, right? Non-greedy means that we're lazy version of the braces going through there. So what does that mean? If we search ha 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 here, it's going to find the shortest string possible going through there. If we do the opposite, it will do the opposite, right? It's going to look for the most of the searches in there as well. All right, you've used the search method. Now we're going to use the find all method. The find all method is going to return every result that we found inside of there. So if I pass it the string, cell phone number, and work number, it's going to match our phone number twice, here and here. If we do a search, it just finds the first one available. If we do a find all, we get back a list of all the phone numbers it found. So you imagine going out to a website, scraping all the data, shoving it through your regex, telling it to grab all the phone numbers from it. It will parse the whole website and grab every phone number, knowing that the phone number should be in this format. Make sense? Or maybe you got an intelligence document and you're trying to search through it for all the phone numbers out of it. This would do that immediately on the fly. I'm sorry to use that example because you're sitting right there. Right. Okay. So as you can see here, it will send a list when you go and do your search. It will return a list back to you. Okay. If you have groups inside of there, for example, we had ones in there for the area code and then the actual phone number, it would give you back a tuple for that result and then pass that into a list as well. Okay. Search, find all. Now, what if we did a len on this list? What would that let us know?
It'll let you know how many there is.
How many you found, right? So if I say Control F and I type it says I found 732 of those, right? It did that all in the fly just by doing Control F. This in your program could do the same thing. You could calculate the regex for everything you're searching through, do a simple len on that result, and that would tell you the total number of matched results. Now, if you wanted to have something cool like this, where it says it's the 321 out of 732, how would you do that? Whichever one you're on, you would just find the index, and the index of that list would give you that result, right? You could end up building something like this in your program if you wanted to. All right. These are all your character classes. So a /D, lowercase d, is going to be any numeric digit. A /W is going to look for any letter, digit, or underscore. Okay. Think of those as word matching characters. A /s lowercase is going to be any space, tab, or new line character inside of there. Right. So if we had something like this where we have /d plus /s/w plus, and then we send it 12 drummers, 11 pipers, 10 lords, 9 late, the old song. If we do that and we do it in this format, it will then parse that entire string out to a list for us with each individual one of those going in there. So how did that work? It's looking for one digit or more, right? That's what the plus sign says. So let's look for one digit or more. We need to have a space, which they have, and then we're looking for one word character or more. And that's what the plus sign, at least one word character in there going in. Once it matches that pattern, it can parse this entire string out and give us all this in a list. If we didn't do it that way, how would we do it before with everything you guys knew? Well, you wouldn't have this as a list, right? It's just a string. So you're going to have to break it into a list and do a for loop and try to do some stuff to see when you find a space.
Steps and just makes it very simple to just boop, you have your list now.
Exactly. So there's some real power behind regexes. It can save you a ton of time and a lot of coding effort. And again, to test that, we could take this string here, pass that into our regex 101. And then up here, we start to build that out. So a /d is going to find our numbers. A plus is going to find any number plus or more, meaning that it's going to find one number and then another number. Notice to regex, this is not 12. This is what? If I take out that plus, 12 is not a number. 1 and 2 is a number in here, right? So until I do a plus behind it, now all of a sudden it's a 12.
Okay.
And again, it doesn't know it's a 12. It just knows it was one digit and another digit and another digit going on down.
So wait, so because of that, is it still going to pick up on those one digit things?
It will pick up on the single ones because it needs to be one or more. That's what the plus does. Yep. Then we're looking specifically for that space, so a /s. And then we're looking for one word character or more. That's what that plus sign is at the end of the W. And therefore it will match on the individual pieces. You can look over here on the matches and make sure that matches what you're expecting it to. Now this could be 1 billion dogs and it would still match on that character, right? If I put 1 million dogs down here, it's still going to match just the same because it matches that format of one or more characters and numbers, and then one space and one or more word characters after that. Yeah.
So could you, or I guess how would you build it to search the numbers but only pick up like over a certain value if it doesn't see it as well?
So what you would have to do is pick up on those characters, and then you would have to, you can only do it by digit numbers, right? So we could go from single digits, double digits, triple digits, that kind of thing. Beyond that, you would then have to parse out that list to see if it falls within a range. You would have to build an additional function for that. Yep. All it's looking for is the actual number of characters going through there. Again, it does not know that's actually 12. It just knows it's 2 digits together. Okay. You can actually make your own character classes. So those were the built-in ones. You may want to build in one that parses all the vowels out of it, right? So that would look like something like A-E-I-O-U, capital A-E-I-O-U. If you put that in square brackets, it's going to pull all the vowels out of whatever you send it through. Okay. If we wanted to find all the consonants, we can actually put a caret right before this, and it would say, do the opposite of this. So we don't have to do B, C, D, F, build out this long one. We just say, here's our vowels. I want to do the opposite of that. I don't have to write a long regular expression for everything that's not a vowel. And in this case, it will find all of the consonants that are inside of there. All right. So the character at the beginning allows you to do a search through there as well. Again, some of these can be reused, so you got to pay attention to when you unit. That upper hello is going to search for anything that starts with hello. Okay. If it ends with hello, it will not count. So a caret character at the beginning of a text is going to do a search in the beginning. If you want to do something at the end, you have to do another symbol that's inside of there. Okay. Once again, all of these are written down here at the bottom. So if we look down here, starts at the end of a string is with a caret, ends at a string is with a $sign. Meaning that if we come back here and look at the $sign, this one means it has to end in one or more digits. It has to start and end with one or more digits, therefore it will match on this entire string. If we have any letters inside of there, it will not match, or a space, it will not match. Cool?
I think so.
Fun stuff. Wildcard character. So say you want to match on just about anything for that one, you can use a period. And so a period or a dot, if I do dot at, it will find things like cat, hat, sat, flat, mat, etc. If you want to match everything, it's a dot star. So if I do first name and a group symbol dot star, last name group dot star, what that's going to do is pull out all the Al Swigerts if I pass it a list like this, right? So now I don't have to grab this part, then do a dot strip to strip off the word first name colon, and then go, you know what I mean? That's what we would do today based on what we know. Where here, if I just do a dot asterisk, it's only going to match on the first name that's provided and the last name that's in here. That's what's going to come out of the mode groups. That star is going to use greedy mode, which will always try to match as much text as possible. If you want to match the least amount of text, you just put a question mark at the end. So for example, if we did this and match the least, if we send to serve a man, it's going to find the to serve a man part inside of there. Okay. Notice how there is another bracket on this side. So that basically finds the first bracket and gives you the smallest amount. If we didn't have that question mark, it's going to find the entire string because it's the greedy side. It's going to give you the most amount of that text. Does everybody see the difference between these two? It's just the question mark is the difference between it stopping here or stopping here. If it's greedy, it's going to find all this text up to the end. If it's the non-greedy, it's going to find the first one and stop there. All right. Let's see. You can match on new lines if you want by using the dot character there. You can also pass in the word dot all, and it would give you that as well. All right. Lots of different options inside of here. Again, just use the tool. If you want to make it case insensitive while you're looking through those, you can pass in a comma re.i. That will make sure that everything is case insensitive. So it's now not going to look for just lowercase RoboCop. It will look for uppercase, lowercase, anything in between. Okay. Anybody have any questions on doing searches and find alls? So remember, search is going to give us how many results? The first one it finds. Just one result, the first one it finds.
Find all is going to give you all.
Find all will give you all of them, and it returns it as a list, right? Okay. You also have, instead of dot search and dot find all, you have dot sub. What sub will do is like doing a find and replace inside your Word document. All right. So it's going to look for this string. It's going to take whatever you want to replace that with, and then it needs the string that you want to do the search through. So if I have agent with a plus W, it's basically going to search through this to find any Agent Alice, Agent Bob, et cetera, and return those results. When it finds those, it's going to replace all of that with the word censored in this case. So censored gave the secret documents to censored. Okay. This will be important when you guys are working through your homework assignment 4. You guys will essentially be doing this. All right. Over here, you can see where it's actually doing a /1 and then doing asterisks. What that does is basically keep the first character that it found and then give a bunch of asterisks on behind it. Regardless of the length of it, it would just give you the asterisks, the 4 asterisks. So it's just a way to clean up code. You guys can manage it to use find and replace. .sub is essentially a find and replace. Okay. If you wanted to count how many you're replacing, you would have to write a little mini thing that would go ahead and start a count. It would do that line. If it worked, then it would go ahead and add another number to that line. There is an option called sub n. Sub n is going to return both the result as well as the total count that it did within that line. And then you would have to count up all of those inside of there. All right, we've dealt with phone numbers and we've had those nice little /Ds, right? Does everybody remember the phone number one? Go back and find the phone number. This one here is probably the most advanced one we've seen so far, finding the phone number. Meaning it's looking specifically for an area code, it's looking for the prefix, and it's working for the actual phone number and returns it like this. Okay. A real phone number in regex, the best one, is going to look something like this one. This is your regex you would want to have. And what that regex allows it to do is find the area code, in which case it could have 3 digits and a dash. It could have 3 digits and a period. So it finds the area code. It finds a white space, a dash, or a period. It's going to find the next 3 digits, a white space, a dash, or a period, 4 digits, and then it's going to look in case there was an extension back behind it. All right. This is a very long regex inside of there. So it's kind of complicated to build that one out, and it's complicated to write that one out. What you can do is use 3 single quotes and then break this down where you have it on a per line basis so that you can add comments for what each chunk does. That's going to be very beneficial if you guys were to ever build really complicated regex up here. Okay, so triple quote syntax allows you to do this side of it here. You can add in your .ignore case, .ignore all, or even verbose at the end of that. And what that will do is add little features like going all the way through. So there's a project here for you to be able to sanitize phone numbers and email addresses. I encourage you guys to play with that one to see if you can build out what that would look like. Here's an example of how to build those out. All right. There is also a homework assignment down here, if I can find it. Date extraction. This used to be a homework assignment here, which was a password. So you need to write a function that uses regular expressions to make sure the password string is secure, basically, right? And then it has to have at least 8 characters long, appears both uppercase and lowercase characters, has at least 1 digit, and you may need to test that string against multiple patterns to make sure it's correct. So what would that look like if we were to build this one out?
I have no clue.
Well, let's fire up idle. You start at the beginning.
We're done.
Right? Okay. So we know if we're going to play with regular expressions, we have to have what? Import RE, right? You always do that at the top of your program. Never in the middle of your program. Always do your imports at the top. All right. It says write a function. So what do we know we're going to do right off the bat? Def, and then whatever we want to do. So password validate. I don't know, I'm making something up, right? This password validate is going to take in some kind of text. So we're just going to put text there. To make sure the password string that is put in is strong, okay? A strong password is defined as having at least 8 characters. So let's do a little note here. 8 characters, 8 plus char characters long. It needs to have both upper case and lowercase, and has to have 1 digit. All right. So the first one, what would you guys have done in the past in order to make sure that it meets that requirement? So just to test this little program, we're going to add this down here and say something like print, please enter a password. And we'll get password equals input. And then a password validate. And we're going to pass in our password for that. Okay. We're going to throw this in a while true just so we can keep it going. And then we need to actually write the code for this side of it. So without regular expressions, how would you guys write that first test? Yeah, we could use the len, right? So if the len of text in this case is what? Greater than or equal to 8, right? Then we could go ahead and return true. Or we could at least go on to the next test, right? So here we're going to say, how would we do that in a regex way? So to get started, let's go back to our text. Let's scroll up. Way back to the beginning. Okay. And let's look at how we would build out that regular expression. So starting here, let's just copy and paste this one in. So we have phone number regex. We're probably going to call this password regex. Or in this case, we'll call it our len regex, right? And what we're wanting to do is make sure that it has at least 8 characters. So what would that look like here?
So when we do, I know we have to have a plus.
Wouldn't necessarily be a plus. Let's look back over here at our regex builder. Let's look down here at the bottom. If we want 0 or more, we would do an asterisk. If we want 1 or more, we would do a plus. If we want exactly 3, we would have the 3 in the braces.
So I'm guessing we have that 8.
Here we have 3 comma, which says 3 or more, right? So we're going to have something like 8 comma, right, in order to get it in there. So let's go back to our idle. Now they have an A in front of there. That's to check A's. What do we want to check for? Yeah, in this case, any kind of word character, right? So does anybody remember the symbol we can use for word characters? That's the word boundary. You're not far off here. In this case, a word character is just a lowercase w. All right. Our curly brace, 8 comma curly brace. If we go back and look at our tool, remember this is what we want to match. The slash W tells us that we want to match on any word character down here. So if we come up here, clear this out, we clear this out, and we type in passwords like password, something, 123, my pass, something like that. Then we're going to come up here and look for a slash W, curly brace, 8 comma, curly brace. That's going to look through all of our results and see the ones that are at least 8 characters long. And we'll notice over here that password and something 123 actually worked. Okay. Now you may have a bunch of other passwords you want to test over here, something like password 123. Something like that. Doesn't matter. Okay. Notice it's only going to match on the ones that have 8 or more characters coming through there. Now, this actually matched on part of this string in here. So we would want to make sure that it would actually group that together. So we would want to put parentheses around that, where it would only match the ones that would be grouped in there or else. Now, in this case, it's still going to match that. So for now, we're just going to leave that out. Okay. You guys built your first regular expression that is the equivalent of doing len, but it's going to make sure that we have 8 or more characters. Now we actually have to use that, right? So this is where you had your mo. So you can just copy this right out of your homework or out of your example here. And we have mo phone number regex. Well, we know we're going to change this name to len regex. And we're going to do a search through whatever text that we want to search through. In this case, it's our variable called text. Okay. That returns us mo, which is our quote match object. Now all we have to do is figure out if there is something to mo, right? So if mo dot group, then for now we're going to say print it is longer than 8 characters. Else print password is not long enough. Now, we're just doing this for a test. The assignment doesn't want us to actually print anything, but for the sake of being able to see if this works right, let's try this. So I'm going to save our little program here. Go to our downloads. Okay, so we're going to try our password. And it turns out that the word password is longer than 8 characters. If I call pass, I get a crash. Okay. Now, crash is because mo did not have any group. So let's go back here. The reason mo didn't have a group is because we didn't get any result, right? So we can't check on mo.group. We need to just check on mo itself. Did mo actually have a result? So let's try that. Let's make sure our word password is working. It is. We try pass, and now it says it's not long enough. Does everybody see the difference there? If we check on mo.group, if there is no mo.group, aka there was no result, we wouldn't get anything back. So if mo allows us to check this. All right, so this was our first test. We'll just stick that here. And in this case, we'll say if not mo, then we can say print password's not long enough, all right? If it's valid, then we're going to move on to the next test. So what would be the next test? Uppercase and lowercase characters. So how would we check for uppercase? We're trying to use regex at this point. Yes, you could. You could at least say is upper, but is upper would just do what? Right, but what would it actually be checking for? All uppercase, right? So you couldn't just check for a uppercase character. You would have to see all at that point. So if you didn't do that, then to write a function or some way of doing that, you'd have to do a for loop through text. So for char in text, if char dot is upper, then we could set something to true, right? We could say something like uppercase equals false. And if this is true, then we could say uppercase equals true. And then we could go ahead and test later on. If it was, thumbs up. If not, else. In this case, we need to write a regular expression for this. So we could start out exactly like we did up here. Just copy and paste this down. And let's call this our uppercase. So upper regex. And then how do we search for an uppercase character in here? Well, there is no specific one that would tell us how to do that. So we need to create our own. Okay. That was our square brackets. So if we go down here to the regex and you look here at your square brackets, a character in the range of A to Z lowercase or A to Z uppercase. Notice how they just put A dash Z and through there. So we're going to do the same thing. Pull this back up here real quick. We would have A dash Z, right? That's going to make sure that there's at least one result in there. And we're going to do our same mo. In this case, we're going to do our mo upper, search, and text. Okay. Now that we found that, we can do the same thing. If not mo, then print no uppercase character. Lowercase, essentially, we're doing the exact same thing. Only now we're not going to be upper. We're going to call this lower. Lower. And lower. And we're going to change this uppercase A to Z to lowercase a and Z. And of course, change this to lower. Now, we could do this in one long regex, but what's the problem if we do this in one long regex? Does anybody see why there's a benefit to breaking this out?
Like whether it's long enough.
You got it. If we do just one check, then it has to pass everything or it fails. If we do it this way, we can at least tell the user, hey, you're missing an uppercase or you're missing a password length or what. All right. For now, I want you to break it out. We can go back at the end and then check for everything in between. So if mo, we have uppercase, lowercase. What's the last one? At least one digit. What would that look like? You guys have this same functionality. We could call this the digit. The digit. And no digit. What would we put in here? Yeah, the slash D. And what are we looking for? At least one of them, right? So we could do a plus. And that would give us at least one result. In this case, we could leave the plus off because as long as we find a number in there, we're fine. We may get 20 results back out of there. We don't care because we're using search is all we're looking for. Okay. That will get us back our digit character. And it would go back here and print. And because we did these as individual ifs and not elifs, then it's going to give us back any of those problems with that particular password. That makes sense? So somebody asked me a while back on the if statements, why would we use just multiple ifs like this and not elifs? Well, if I did an elif here, let's just try that. It's actually because I got other stuff in there. I can't do it that way. But if you did elifs in there, what that would do is check for one, then check for the next one, check for the next one on down. If we do them individually, I can actually return individual results for it not matching those conditions. So here I type in pass. We can see that I meet or I don't match on 3 of our conditions. No digit character, no uppercase, and no password. I do match on which one? Lowercase, right? So if I now use the capital pass, I now am one step closer to making this work. If I use capital password, I just don't have a digit character. And if I have password with a 1, I get no response. That basically tells me that I passed. All right. So what we could do is set a character like this. And we could say pass equals false. And we could say here, or pass equals true, rather. And if this doesn't work, then we could set this pass equal to false. Here. Here. It does. That's why it's highlighting in orange. So we could say something different there. Works would be fine. And what that allows us to do at the very end is just do a check on works to see if we failed anywhere along the way. So if works, then print password is valid.
Change your logo in case you have passes still.
Thank you. And so what that will do, if any one of those fail, it will set it to false, and therefore it won't get to the last one. So pass, there we go. If I get password, looks like it's working. Password is valid. Cool.
And you can break that too, right? So it doesn't show the enter password.
Yeah. Right now I just have it in an endless loop that's going to go forever. We could also check to say, hey, if it does that, then in that case, what we would do is say password is valid, return true. And when we do a return true, it'd come back here. We could say, where's my check? Did I lose it? Oh, my screen's off. There we go. And we could say if password break. And what that does is if this returns back true from up here, then this becomes true, and then we go on. But it only does it at the point it works. So if we try this again, password not working, password works, password 1 is valid, and then the program ends. Cool. Now, there's a bunch in there. As we all know, good passwords are going to have probably some kind of special characters in there as well. And so you guys can define your special characters in there if you wanted to, right? So for example, we wanted to make sure there was a $sign, plus sign, equal sign, etc. All we would have to do is take this section here, copy it down for another chunk, and we could say special. And then in here, what would we do in order to validate those? We did something similar up above. What's up? Not pipe, but we did it similar for lowercase and uppercase. The square brackets, right? So a square bracket allows you to define your own custom match case. And in our case, we are looking for dashes, plus signs, equal signs. Yeah, we could do at, basically go down the character here for all those. If we wanted any of those to be valid, we would just put them inside there. If we got a result, we matched and we're good to go. So you guys may see this on websites where they all have different versions of special characters as to what they could be. There's multiple reasons for that. One, If you are doing SQL and stuff like that, you may not want some of these special characters, especially if your code's not escaping them. And if it's not escaping them, that's really bad code. But there's special characters that you could use, for example, this upper or the and symbol inside SQL, and you could break websites doing that. It's called SQL injection. You guys would learn that in cybersecurity. So we would want to make sure that we would never accept any of those kind of characters in a password. Otherwise, it could be somebody actually trying to break our system. So for example, we would probably never allow and we would probably never allow equals inside there as well. But you might want to allow something like exclamation point, etc. Now this dash is going to cause a problem. We would have to escape that because what does dash mean? Yeah, it'd actually be 2, right? Just like we did up here, A2Z, it would actually think it was exclamation point to plus. So we would have to not do that one. If we wanted it, we would have to escape it. But we could test this. If we take this little string, we go back to our regex 101, we pass that in, notice that that's something stronger ends up matching at this point because we have that $sign in there. We could do password 1 with an exclamation point that matches. Password with a caret symbol. We could see that matches, etc. So this is a great way to test it, is come back to this website, dump your regular expression in here and see if it works. Make sure you leave out the single quotes around this, right? Because if you put the single quotes in, it already is using the double quotes, as you can see here. If you actually copy this, it would do it. Notice that this GM means what? In this case, it's looking for global multi-line. So it's going to be able to take in multiple lines as it goes through there. You could set this to sensitive, case insensitive, that kind of stuff to match in if you wanted to. You would have to set that inside Python. Okay. So this is one way to write a password validator. I would go through and do a little bit of practice with regex. Your homework assignment, when you guys see it, it won't be this week, is you guys will get a text document and you guys are to search through it and find all the word Sherlock Holmes in there. And so you would have to set up a regex to find Sherlock Holmes. And then you have to search for the word the and replace all of the does or do a count on the word does. On the Sherlock Holmes, I make you guys replace the word Sherlock Holmes with your name. It also has to count how many times it did that. So we'll talk about that homework assignment when we get there. Anybody have any questions on regex? I do not cover a whole lot of regex on the midterm exam. It's very, very basic what I'm asking for in there. Like, what module would you import?
Random int.
Yeah. All right, I'll conclude this video. Yeah, exactly. I'll stop this video.